Good day! We are Jeleina and Gayle, and we are going to tackle the special lines in a triangle, and those are height, angle bisector, median, centroid, which is involved in the medians of a triangle.
We have a triangle here which has the measurements 10 centimeters, 12 centimeters, and 14 centimeters. 12 centimeters for the baseline segment BC and 10 centimeters for AB and 14 centimeters for line segment AC. To find the height, we must first find the semi-perimeter, which can be found by adding all the three sides and dividing them by 2. So 10 plus 14 plus 12 divided by 2 is 36 divided by 2 equal to 18.
Now that we found the semi-perimeter of the triangle, which is 18, let us proceed to getting the area of the triangle using the Heron's formula, which is A is equal to S times S minus A times S minus B times S minus C. S being the semi-perimeter and A, B, C are those measurements from the triangle. Now let us proceed to the substitution of the values in those variables. S 18, so 18 times 18 minus 12, 18 minus 14, then 18 minus 10. Now let us now factor the numbers inside the radical sign. For 18 we have 6 and 3. Then for 6, and then for this 6 we will just put it as 6 again. Then for the 4 again, and for number 8, 4 and 2. Let us remember that 2 square roots of the same number make a rational number. So for this case, we will put this number outside the radical sign. So we have 6 outside the radical sign, and the same goes for number 4. So what stays inside the radical sign are numbers 3 and 2. 24. 3 times 2, 6. This is our area.
That we found the area of this triangle using the Heron's formula, let us go back to the standard formula for the area of the triangle. Area is equal to base times height over 2. To get the height, we derive h from the area. So we have h is equal to 2 times the area over b. So we just multiply the area that we got from the Heron's formula, which is 24 square root of 6 to 2. Over base, which is 12 in this case. So 48 over 12. 48 divided by 12 is 4, so 4 square root of 6. Therefore, this is the height for this triangle.
This time, I am going to show you how to find the length of an angle bisector of a triangle given the 3 sides. So first, angle bisector is the line or line segment that divides an angle into 2 equal parts. So for instance, given this triangle with measurements 10, 12, and 14, we need to find the length of the angle bisector, which is in this case is line segment 2. In finding the length of an angle bisector, we need to remember the formula d squared is equal to bc over quantity b plus c squared multiplied by quantity b plus c squared minus a squared, where d is the angle bisector, a is the base, and b and c are the legs of the triangle respectively. Knowing this formula, we can now find the length of the angle bisector. And in order to come up with that, we just need to substitute all these values to this equation. So d squared is equal to 12 times 10 over b plus c is 22. So this will become 22 squared. The same goes with this. So this will become 22 squared minus a is 14, so 14 squared. Simplifying this equation, d squared is equal to 120 over 484. And in this part, we can apply the concept of difference of two squares. This will become 22 plus 14 multiplied by 22 minus 14. This fraction can be reduced to its lowest term, so this will become 30 over 121. And this will become 22 plus 14 is 36. And 22 minus 14 is 8. Multiplying all the numerators will give us 8,640 over 121. And in order to find the value of d, which is the angle bisector, we need to get the square root of both sides of the equation. So, square root of d squared is equal to the square root of 8,640 over 121. So d is equal to the square root of 8,640 is 24 square root of 50. And the square root of 121 is 11. So this is the length of the angle bisector.
In this triangle, we must find the value of this median, and we can do that by using this formula. MA is equal to 1/2 square root of 2 quantity b squared plus c squared minus a squared. Then we just substitute these measurements to the corresponding sides in this formula. So a is equal to 14 and b is equal to 12 and c is equal to 10. So let's proceed to using this formula. 1/2 b squared 12 squared plus c squared 10 squared minus 14 squared 1/2 144 plus 100 minus 196 1/2 244 minus 196 488 minus 196 We factorize the number inside the radical, which is 292. We will get 1/2 square root of 2 times 2 times 73.
the product of two square roots of the same number make a rational number. So 2 will be placed outside the radical sign, thus making 1/2 times 2 times square root of 73. 1/2 times 2 is equal to 1, and the square root of 73 is at least. So square root of 73, that is our median.
Now, we are on finding the lengths of the segments of the median. We know that the centroid is the point of intersection of all the medians in a triangle. This point is the centroid of this triangle. In this triangle ABC, we only gave value to the line segment BF of 78 centimeters. Since the centroid divides the median into two segments in the ratio 2:1, we can let X be the value or be the length of line segment GF. And since the longer segment, which is in this case is line segment BG, is twice the length of the shorter one, we can let 2x be its length. Obviously, the sum of the two segments is equal to the length of the median. So we will have the equation 2x plus x is equal to 78. So 3x is equal to 78. Dividing both sides of the equation by 3 will give us x is equal to 26. Now that we have found the value of x, we can now substitute this value to this. So, line segment GF has length 26 centimeters, while line segment BG will have times 26. So line BG has the length of 52 centimeters. So the length of line segment GF is 26 centimeters, and for line segment BG, 52 centimeters.